quick, I want to talk about absolute value. So absolute value is a measure of distance from the origin. Our origin is 0, right? We can kind of think of that as home. So if I'm at work, I don't say I am -7 miles from home. No, I say I'm just 7 miles from home. So because absolute value measures the distance, that distance is always going to be positive. So let's take a look at -3. How far away is -3 from 0? Well, it's 1, 2, 3 away from 0. So the absolute value of -3 is just going to be 3. The same is true for the absolute value of +3, right? +3 is also 1, 2, 3 away from 0. The only couple interesting cases, first, the absolute value of 0 is 0, right? If I'm home, I'm already there, so I'm 0 from home. The next thing is that absolute value bars, we treat them kind of like parentheses when it comes to order of operations. So if I have the absolute value of -4 with a negative on the outside, I need to simplify this first. Well, the absolute value of -4 is going to be 4, and then I still have this negative on the outside, so it becomes -4. The distance between points on the number line is going to be the absolute value between their coordinates. And friendly reminder that distance is always positive. A variable, right? The variables are what we're primarily working with in algebra. We're combining like terms. A variable represents a number. Typically we use x. You'll also see y, right? But these variables are used to represent a real number, okay? Because our variable, the value of it can change. You can use any letter except I, right? Because we need I to represent imaginary numbers. So when we're working with algebraic expressions and equations, right? The equations have an equals sign, right? These are made up of terms. And a term is a constant or the product of one or more variables. So for example, I could have a term of 7, its coefficient or the constant that's multiplying the variable is 7. If I have 9a, its coefficient is 9. If I have a single variable by itself, there's an imaginary 1 right in front of it. I like to joke that mathematicians are lazy, so we didn't want to have to go to the trouble to write that 1. Then if I have 5x squared, the leading coefficient on that is 5. So when we evaluate algebraic expressions, that's when we're substituting a numerical value for our variable. So if I have x plus 3 and I say x is 5, I plug in 5 for x. So 5 plus 3 would give me 8. In the second example here, I have 5y minus 8 for when y equals 8. So I would take 5 times y minus 8. So 5 times 8 is 40, minus 8 is 32. So that's how we will make sure we know how to use substitution to evaluate algebraic expressions. So let's go ahead and evaluate the following. If I have 3x when x equals 4, that's 3 to the 4th, which is going to be 81. Let's switch from red. If I have 3x plus 4y minus 6 when x is 10 and y is 2, that gives me 3 times 10 plus 4 times 2 minus 6. So I get 30 plus 8 minus 6, which is 32. If I have 5x minus 2y minus 9 and I want x to be 7 and y to be 8, I take 5 times 7 minus 2 times 8 minus 9. That's going to be 35 minus 18 minus 9. So 35 minus 27, which is 8. Last but not least, when x is 4, I have 2 to the 4 squared plus 3 times 4 plus 8. So 4 squared is 16, 2 times 16 is 32, 3 times 4 is 12, plus 8. 12 and 8 give me 20, so my answer is 52. The domain of a variable is any value, any real number value, because remember we're working the real number line, that a expression can take on. So for example, if I have 2 to the x, are there any 2 times x? Are there any x values that I could not use? No, right? So we can write this in set and interval notation. So any value from negative infinity to positive infinity could be substituted in. In an interval, we'd write this x such that x is a real number. Not super exciting. When things get a little more complicated is when we have rational expressions and rational functions. So let's take a look at 6 over x. What value of x can we not have? Well, we can't have x equals 0, right? If we divide it by 0, that's undefined. We'd break all of mathematics. So I'd have to go from negative infinity to 0, skip over 0, and go from 0 to positive infinity. If you want to look at this on a number line, it kind of looks, well, it looks exactly like this. Feel free again to sketch it out if you need. I always like to do that. Oh, I forgot a parenthesis. There we go. As an interval, I could write this x such that x does not equal, it has a little slash through it, like the no smoking sign, does not equal 0. It's important to note that set and interval notation, these both tell me the same things. They're just different ways to write them. But what if I have 5 over x minus 4? What value can I not have in my denominator? Well, the value that I can't have in my denominator is going to be 4. And I could figure that out by saying x minus 4 equals 0, right? We don't want our denominator to equal 0. So I would find that x equals 4. So 4 is not included in our domain. So we'd go from negative infinity to 4, but 4 is not included. We jump over 4 with this lovely little union symbol, go all the way to positive infinity. In interval notation, this would be x such that x doesn't equal 4. It's important to note that if we're working with higher degree denominators, right, this is a degree 1 equation. We're talking about exponents next, I promise. You may have more than one value of x excluded from your domain.